let's focus on something just as important, the BMS, okay? Because the BMS is the brain, no? You can think of the BMS of the brain of the battery pack, okay? It doesn't store energy, it doesn't produce energy, but it makes sure that the battery works safely, efficiently, and for a long time, okay? The BMS constantly watches over the battery pack and manages things like how much voltage is in each cell, how, how hot or cold is the battery, is how much current is flowing in or and whether the battery needs to be charged, disconnect, or protect from damage. Okay? Imagine if you had hundreds of cells all working together. If just one cell gets too hot or too full, it could cause a serious problem, no? Thermal runaway. So the BMS is the system that notices this and says, hey, stop charging. This is danger, no? Or cool things down. It's getting too hot here, no? Uh, Without the BMS, the battery would be like a car with no dashboard, no sensor, or no brakes. Fast, but dangerous, no? So in this section, we are learned what the BMS does, how it protects the battery, and why it's absolutely essential on any electric vehicle. Okay, let's continue. So let's talk about the functions of the BMS. Management function, diagnosis function, monitoring function, and also have another functions. Okay, first of all, the BMS in the management function, it needs to be able to thermal management, no, to activate or deactivate the cooling system. Electric management, no, activate or deactivate the main relays in order to supply energy to the vehicle, no, and the balancing. That is something that we're gonna talk later. Okay, the balancing cells is very important in order to maintain the state of health. Then we have the diagnosis. The BMS have to be able to diagnose the vehicle. So is diagnosis the state of charge, no? How much energy the battery has, and the state of health, no? If the aging is start or not start in the battery pack. Then the BMS is monitoring, no? The visualization. What is monitoring? The temperature, the voltage, no? All of these parameters. And finally, in other functions, the battery needs to communicate via CAN or another communication languages. For example, link CAN FD, no? With another components like the inverter, like the dashboard, or with other control units, no, the VMs, the VCU, no, for example, and then we have the data log, no, the all these functions that the sorry, all these parameters that the BMS is recording, we need to put it in our data log, no. So as I said before, the topology of the BMS, we have the slave masters. No, the slaves are the monitor of the modules. They are in charge to monitor the voltage and the temperature of every single cell. Okay, and the master, that is the BMS, that measure the current, makes decisions, control relays and algorithms. No, is and also the cooling system, and then the communication between slaves and vehicle. Okay, so the slaves give the information to the master, and the master give the information to the vehicle, to the different control units. And another important thing that the BMS makes, the cell balancing. Why do we have a cell balancing? Well, as I said before, we have an internal resistance cell, and every cell have a different internal resistance. What does it mean? That the cells that have a small internal resistance can charge faster, and the cells that has very big internal resistance are gonna charge slow. Okay, so it's gonna create an unbalanced pack. Okay, so the BMS needs to balancing all these cells. Cells in series, only in series, because if they are connected in parallel, they are gonna balance itself. Okay, no voltage and cell load difference optimize the energy of the battery and increase the cell life. Okay, so as I said before, we want to have a balanced cells like this figure, because if we don't have a cell balancing, our state of health is gonna decrease very high. So let's see what kind of balancing we have. So we have two kinds of balancing, the passive balancing and the active balancing. In the passive balancing, the resistor that is mass a MOSFET for cell discharge. So what happens when a cell is full charge? The cell, the BMS is gonna activate the MOSFET in order to the resistor start to consume the energy of the cell. Okay, so when this happens, it's gonna give time to the other cell to charge. Okay, and then at the end of the charge of the battery pack, all of the cells are gonna be fully charged. That's the reason why the name passive balancing is passive, because it's only happen when the battery is in charging process. And then we have the active balancing. What is the active balancing? Well, thanks to the electronic, we are gonna take energy for the fully charged batteries, and we are gonna give this energy to the discharged batteries. Okay, and this is gonna happen when the vehicle is charging and discharging. Sorry, when the battery is gonna charging and discharging. This is gonna be more efficient, but it's more expensive because we are gonna need electronic devices inside the modules. Okay, then we have an shock estimation for how we can estimate the state of charge of the batteries. Well, the BMS is in charge of make this. We have first of all the open circuit voltage methodology, that is just to measure the voltage of the battery and try to know what is the state of charge. Okay, this is the precision is very low. Okay, especially for lithium ion batteries. Why? Because as you can see here, it's not the voltage is very constant between all the curve. Instead of this, of the lead acid, you can see how the voltage decrease when the charge start to decrease. Okay, so for example, in a 12 volts lead acid, if you measure the voltage and you see 12 volts, you can say it's full charge. But in a lead acid, you see 6 volts, you can say is very discharged. Okay, but you cannot make this in lithium ion batteries. Why? Because the voltage is gonna maintain equally in all the line. No, 100% of state of charge, 12 volts. 20% of state of charge, 12 volts again. So you cannot to know the state of charge with this method. Is very good for other chemistries. Okay, but we have the column counting methodology. What is the column counting methodology? Well, the BMS knows the state of charge, the initial state of charge, and gonna start to rest uh, the current, okay, the current of the battery that is consumed in uh, for uh, for the time. Okay, so you have the current for the time, you have an efficiency and a capacity of the battery. No, you are resting, this is your initial one, and that this is the energy that you are consuming. So you are resting all the time the energy that you are consuming, and you are gonna know the state of charge, and it's gonna be more, the accuracy is gonna be better. No, the error is less than 100%. Less 1%. Okay, the error is less than 1%. The column counting. Okay. Then for the thermal management, to manage the cooling and heating of the battery pack. Okay, to achieve the best working windows, to optimize the performance of the battery pack life. Okay. For example, we are seeing here the Tesla cooling system. As I said before, the cylindrical cells have a gap between them. No, you have a space between the cells, so you can pass between them a pipe. Now this pipe is gonna be the cooling system, as you can see here in another picture. So you can cooling better the battery pack. So there are a lot of cooling systems on the market. Thank you for your attention, for your kind attention, guys. For any question, more details of information, feel free to contact us, please.